All right, here we go. So, could have given you a pre-quiz, but most of the stuff we have hit prior, but I definitely want to do another flyover. So, I'm going to pose some questions, and I'm going to give you some time to think about the answer before I give you the answer. But we're kind of going to move through these. So, what is Newton's first law of motion? Let's think about it, and then how will a moving object move if no unbalanced forces are acting on it, and how will an object move if an unbalanced force is acting on it. Newton's first law of motion: an object at rest will stay at rest, an object in motion will stay in motion if forces are balanced. Okay, if there no unbalanced forces are acting on it, it will continue to move, either to stay at rest. No, sorry, a moving object will continue to move at a constant velocity. If there is an unbalanced force acting on it, the velocity will not be constant. It will either speed up or slow down. Experience acceleration. Good with that? Okay, so balanced forces. If you had 7 newtons going this way, 7 newtons going this way, the net force, the total force, the resultant force would be balanced. We would say that the net force is equal to 0. That is balanced. Okay. So does everybody go with this? Like the net force, the total force is equal to 0. 7 going this way, 8 going this way. That would be unbalanced. So the net force, total force does not equal 0. Okay with that? Inertia, what is inertia? What does an object do? What does an object's inertia want to do? If the object's at rest, what does the object's inertia want to do if the object is moving? Inertia is the object's natural tendency to maintain its present state of motion. It's at rest, the object wants to stay at rest. If the object is moving, the object's inertia wants to continue moving at a constant speed in a straight line path. Some people call Newton's first law of motion the law of inertia. See the correlation there? That. This is something new. How much inertia an object has is 100% determined by the mass of the object. Okay, the more mass something has, the more inertia it has. The less mass it has, the less inertia it has. Okay? Inertia and mass are solely determined by each other. Good with that? Okay. Newton's second law of motion, you've seen it before. You're going to see it again. And this is the net force is equal to mass times acceleration. If you were to ask anybody who has taken physics in the past, and you ask them, hey, what's the most used equation? They're going to say force is equal to mass times acceleration. If F equals ma. Okay? To describe that in words, I'm going to rearrange it mathematically a little bit. I'm going to divide by mass. Are you okay with that arrangement there? So, the mass is inertia, determines inertia, and this wants to maintain present state of motion. Wants to maintain the present state of motion. We could personify inertia. It's like, dude, man, just keep doing what we're doing, man. Don't rock the boat. Let's just maintain and status quo. This is good. Change is bad. We just chill out, man. We're good. Okay, that's inertia. Force, on the other hand, wants to change the motion. Okay, the force wants to change the motion. If we could personify force, be like, come on, man, let's do something different. Woo! Like, let's check things up. Like, change is good. Embrace the change. Like, we want to mix the pot. Like, so do you see the difference between force and inertia? The conflict of interest. Okay? So, acceleration is the result of this battle. This is the result of the battle. This is how quickly motion changes. The rate at which velocity changes is acceleration. How quickly the motion is changing. Okay? You cannot figure out acceleration solely dependent upon, determined by the force. It is this ratio of force to mass. Force is getting in there. Let's change things up. But inertia is like, dude, come on, settle down, man. Quit. And so, but force always wins. There will be acceleration if it's unbalanced. But how much? Well, it's that ratio, force to mass. Good with that? Okay. Net force. In business or economics, you heard of net gain. That's like, so you sell something and you get a bunch of money in, but then you got, oh yeah, I got to pay for all that stuff that I just sold, all the materials, the labor, all that stuff. So after you pay all your expenses, what you have left over, that's your net gain. Does that make sense? Okay, your net force, your total force after everything's said and done. What do you have? What's at the end of the day? Okay, sigma is a mathematical symbol that we use in math that says sum of the total, the net. Okay, so we would read this: the net force is equal to 0. The total force is equal to 0. The sum of the forces are equal to 0. Good with that? Okay. So, the unit of force, I've alluded to this past, is newtons. In America, we use pounds, but in physics, we use newtons, as in Sir Isaac Newton. Okay. where a Newton comes from is this. Mass is measured in kilogram. In chemistry, you measure it in grams, but in physics, we measure it in kilograms. We're a little bit more macro-sized here. And acceleration has units of what? What's the unit of acceleration?
Meters per second squared.
Good, meters per second squared. So, units are kind of like, I'm going to make this analogy, primary colors. Okay, primary colors, red, yellow, blue. Mix and match those colors together and you get different colors, a whole spectrum, okay? The primary colors of units, kilograms, meters, seconds, those are all technically called SI units. You can mix and match those to come up with a whole assortment of different units. Okay? So, to explain this conceptually, you have if an object experienced a net force of 1 Newton, and that object had a mass of 1 kilogram, it would experience an acceleration of 1 meter per second squared. All right with that? Okay. All right, did that. Last thing, we talked about this last chapter, but whatever the direction of the net force is, that's the same direction as acceleration. The force causes acceleration. Good with that? All right, we got some factoids. Let's start applying it. So, by the end of this lesson, you'll be able to describe what inertia is and does, and also be able to calculate how something moves when forces act on it. Give that one a shot. Tell your neighbor and tell them why you think so.
Because he said that's the only thing that's affected by it.
That's not wrong.
Correct answer is A. Everybody good with that? A, solely based upon inertia. So inertia is not momentum. We will talk about momentum in a couple months. Okay? Inertia is solely based upon the mass, not the motion. Okay? It affects the motion, but it's not determined by the motion. Not the emotion. By motion. Good? Take that one off. A lot of words, I apologize. Tell your neighbor.
Slow and my dad's like, I'm like, calm down. My name is 35 miles an hour. unfortunately, I say it's like a slow, like,
I'm like, you're fine. Calm down.
because when Drew's driving, he's afraid, like,
Correct answer is B. What do you say? We got two B's. Correct answer is B. Books are moving. You stop the cars like, oh, I just want to keep on going. Good. Next question.
There's a little bit.
I don't want to, like, I want to get like a I don't want to be there for 3
Like
years.
it's things like.
But then also, like, I do. You know what I mean?
no, I don't get it.
Like, I don't want to have to be there, but I'm like, I want to get it done. You know what I mean?
I like the really cool.
Is it chill? Is it fun? Have you been in there for 6 periods? Because I think we're going to need to stay there like the full 3 months.
He said he doesn't know what he's doing in his AP stats class, so we might just have to like.
We can always just do it ourselves and then ask questions.
Yeah, well, we tried that.
Well, I did process by myself today, but I also did the easier ones that you didn't want to do with me.
We're right.
Correct answer is? Correct answer is E.
It's like the best.
Educated elephants. Okay. So, you're at rest, you want to stay at rest, but the chair is pushing you forward to stay with the jet that's speeding up. Okay? Let me try to like bring this home. You feel when you're experiencing acceleration. Your gut will like, ugh. That's because your guts, there's some sloshiness to them. So when the back is being pushed, your spine's pretty rigid, but your guts are not so. And so it stays at rest, and so there's this idea like I'm trying to stay at rest and my back's like, and so you feel weird. When you're driving, try to be aware of what your gut is saying. If it feels weird, you're probably experiencing acceleration. Okay? Try it. Okay? You know when you're experiencing acceleration. All right. Give that one a shot. Have a conversation now.
I don't know. How is it?
This unit really confused me in AP Physics. This is the unit that caused me to drop.
And that was like a month ago. Danielle.
Correct answer is an object in motion wants to stay in motion. It doesn't require any force. It's like, yes, I'm doing exactly what I wants to do. That's why air hockey tables look so cool. It just wants to continue moving. It doesn't require any more force. Is everybody good with that? Okay? So, inertia is not a force. It's just what the object wants to do. Does an object have mass? Is that a correct statement? Yes. Yes. So therefore, an object can have inertia. An object has a lot of mass, it has a lot of inertia. Okay? But an object cannot have or possess force. Okay? It is incorrect to say, man, that guy has a lot of force. No. You can say, man, that guy can exert a lot of force, or exerts force, but you can't have or possess force. Force is something on the outside that two objects interact and cause. Get at that? Okay? Thumbs up when you have a guess. Tell your neighbor what you think.
This means that your dad wants to say
Correct answer is B. Is it possible for your car to drive down the road going at a constant speed in a straight line path? Is that a possibility? Yes, it's called cruise control. Is your car experiencing forces? Stick your face out the window when you're rolling along at constant velocity. Yes, your car is experiencing forces. How is it able to move at a constant velocity? Because there's other forces that are canceling stuff out.
I thought if force was equal, if net force was equal to zero, that it wasn't moving.
Or moving at a constant velocity. It's doing, okay, here, if you're a note type person, this is huge. Okay? Huge concept. We will hit this multiple times. If inertia is doing what it wants to do, staying at rest, which we don't have a problem with, the net force is equal to zero, or if it's moving at a constant speed in a straight line path, constant velocity, that's what inertia wants to do, then the net force, you know definitively that the net force, the total force is equal to zero. It's doing what inertia wants to do. It's like, yes, I love this. Keep on doing what we're doing. There is no, like, forces are balanced. Okay? Got 2 more questions. This one and the next one. correct answer is D, dangerous dinosaurs.